All right, so this is chapter 3, graphs and functions. Let's get started by going over what we know about graphs and functions. Emily Craig.
Yes.
What do you know about graphs or functions?
There's an x and a y-axis.
Perfect. With graphs, there is an x and a y-axis. Mark, the x-axis is the horizontal. The y-axis is the vertical one. Okay? It's the vertical one. Does that make sense to you? Now, it's very important to know because we're going to be talking about shifts later today. Not like your shift at work. We're going to be talking about moving a graph, like different directions, okay? And how to find the coordinates of that. Now, a function is just a specific type of graph. It has a specific set of rules, so there's nothing fancy. And I've said this all year, that it's important to know what things look like before going in. So in this chapter, we're going to be talking about linear functions. They're going to be a line. We're going to be talking about quadratic functions. They're going to be in the shape of a U or an N. How do I know that? I've done it for many, many years. And this is me telling you that's what it looks like. So when you're plotting points to graph your function, if you get a point that kind of looks out of place with a quadratic or a cubic, then you know you need to go back and check your work. Okay, now how do I know if something is linear? Well, it's linear if the biggest exponent is 1. And it's quadratic if the biggest exponent is 2. Cubic, 3, quartic, 4, so on and so on. Now, here are like the two big ones. The purple one on my screen, that is a cubic. It's kind of shaped like an uppercase N, okay? Now, quadratic is the green. That's like your U shape, or if you flip it, that's your N shape, okay? So let's talk about graphing. Now, Emily said we have a X and Y axis, which we do, okay? And now in order to graph, I need points, right, Mark? Yep. So, in order to get those points, we can use our graphing calculator, or we can do it old school. I like to do it old school, just because I did it last period, kind of new school with the graphing calculator. It didn't work too well for me. So technology was kind of failing me. So I want to do it old school. Now, new school, you could simply hit the y equals on your calculator. You could type in 3x plus 2, and then you could hit the blue button or the yellow button. That's the second button, and then you could hit graph, and you get a table. And your table will come up, and it'll tell you your answer. It'll tell you each of these points. But inevitably, Marcus, when you're taking the SATs or PSATs or the Keystone or college entrance exam, your calculator will fail you. It always does. Okay, always fails. Moral of the story, always bring 4 AAA batteries, okay, just in case. Second, it's important to know how to do it by hand in case you don't have it. So here's what we do. It says we want to choose these values, -3, -2, -1, 0, 1, 2, and 3. Now, Owen.
Yeah.
First off, congratulations. You now have the same number of wins as the Eagles. Second, do you know why we choose -3, -2, 0, 1, 2, and 3?
Because it's like the first couple numbers on a graph.
Very good. It is the first couple of numbers, but I can choose any number. But let's be honest here. Multiplying something by 12 is not as easy as it is multiplying it by 3 or 2. So we try to choose simple, easy points. Now, how do I show my middle column, which is my work column? Well, I'm simply going to replace the X with what it says over here in this column, okay? I'm just going to replace my X's with these numbers over here. So in this one, it's going to be 3 times -3 plus 2. You guys writing this down? This one would be 3 times -2 plus 2. here, this would be 3 times -1 plus 2. This one would be 3 times 0 plus 2. This would be 3 times 1 plus 2. 3 times 2 plus 2. And this is 3 times 3 plus 2. Rachel, is that okay with you? Makes sense, right? It's easy. Now, to get this column, this is my solution point. It's a point, okay? Now, a point involves x and a y alphabetically. So I would do 3 times -3, that's -9, plus 2, that's -7. So this would be the point -3, -7. 3 times -3 plus 2. -3, -7. Okay? This one.
How do you get 2 numbers?
X, right there. So this is, Mark already know it's -2, and then whatever this is. So it's going to be 3 times -2, it's -6, plus 2. So it's -2, -4. Now, I'm not always in the market for looking for easier ways about these problems, okay, Mr. Kitchen? But sometimes there's an easier way to cook up the answer. They get worse. Now, Mr. Kitchen, there's some numbers up here in my problem, right? Y equals 3x plus 2. Each of those numbers has a special meaning here, okay? Now, I want you to see, as I'm going through this and putting up the answers, see if you can figure out where the 3 comes into play and the 2, okay? This problem is going to be -1 and -1. 0, 2, 1, 5, 2, 8, and 3, 11. Which, by the way, 311, banned. Okay. They need to know these things. Now, Mr. Kidd, did you sort of see where the 3 and the 2 come into place?
Yeah.
Where?
It's +3 on y.
Very good. For those of you at home who couldn't hear Mr. Kitchen cook up the right answer and make me a spectacular assumption, okay? That was a little stretch, but it's the attempt that matters, okay? He said the y's, I'll get you, I got you. The y's are going up by 3, which is linked to the 3 in front of the x, my slope. The y's are going by 3's. Very good. The 2, where does that come into play? The 2. You want to hit?
Yeah, sure.
Right there. That's my starting point. That 2 corresponds to that 2. Not this 2, but that 2. And for those of you at home, I'm pointing to the one that is corresponding to x equals 0. That is my starting point, where I start my graph. And then I go up 3 to the right 1, and we have our graph. Now let's plot these points. Let's go over to our graph and plot -3, and it's -7. We're going to plot that, and I hope that these points turn out all right. -2, -4, -1, -1, 0, 2, 1, 5, 2, 8, and 3, 11. Rock, paper, scissors, shoot.
That's it.
Okay, now it's one and done.
All right.
But I always throw rock.
All right.
You ready?
Yeah, I'm ready.
Maybe I don't. No, I always throw wrong, but they could be wrong.
No, I still rock. All right,
Maybe.
ready? Rock, paper, scissors, shoot. Rock, paper, scissors.
No, I like the method.
lost.
You just made sure he was actually stay solid. I like it.
Do you have the code?
Well, he didn't. The code? Yeah, he didn't do it.
I know, that's why I asked.
Yeah, no, it's up there. It's okay. I'll yell at him inside. All right, so now we have our points, and we can connect our points. Let's see how good I am. Ready, up. Not bad for only having one shoe on. I know, it made you look. It was good. It was good. It was good. All right, so now I started the whole class by telling you I should know what my graph looks. It's linear. That means a line. I know I got it right because my points are in a line. I can't draw a line, but they're in a line. So I knew I did this problem right, or at least I reassured myself I did it correctly. Now, these problems I'm rolling through, okay? We don't have a ton of examples just here that we can do together, but I'm going to go over them. Now, the distance formula. Mr. Emmy, who was your math teacher last year? Was it Mr. Beatty? Warner. Warner probably taught you this crazy thing called the Pythagorean theorem. Yeah? Do you remember it? At least you're honest. At least you're honest. Mark? Yep, that's the slope point, or what is it? Slope intercept point. Okay, do you remember it, Mr. Kitchen? It's perfect.
Yeah, that's it.
You baked that to the right temperature. Okay, now, so a squared plus b squared equals c squared. That is the Pythagorean theorem. And the distance formula is that. It is a squared plus b squared equals c squared. Your, kind of, so to say, a squared is the difference between your x's. It's that piece. Okay, notice a squared. This piece is kind of like your b. Notice b squared. It's the differences of your y. Now, what is d? Well, d is like when I asked you to find the length of your hypotenuse. What did you do? You did a squared plus b squared, added them together, you took the square root. That's all this is. It's the Pythagorean theorem. But each time I'm asking you to solve, okay, to solve for C. Okay, makes sense? Now, down here, okay, this is an example problem. But my words of advice is, and I'm going to go back up because I have a little bit of room off to the side here. My words of advice, and you won't find this anywhere. Right, this is kind of like a little harmonism, if you will, a little bit of harmony. Okay. There's a little bit of steps here. Okay. Whenever we are dealing with coordinate points, okay, this is what you probably should do. And it's the same thing over and over again. Okay, one, you should always label your points. Always label your points x and y, whatever it is. If you have 2 points, it's x1, y1, x2, y2. If you have 1 point, it's just x and y. Step number 2 is to write your formula. Now, that formula might be m equals y2 minus y1 over x2 minus x1, your slope formula. That may be y equals mx plus b, like Mark said. It might be your distance formula, okay? D equals the square root of x2 minus x1 squared plus the quantity of y2 minus y1 squared, okay? That might be the formula you write. But in any case, you should always label what you have so you know what you're substituting in for. And that brings me to 3. Step 3 is to substitute. So you're going to take what you labeled, you're going to take your formula, and you're going to substitute in what you got. And the fourth step is we need to simplify or solve. They're kind of like the same thing to me, but there is a difference. Doesn't really matter. You'll get it. It'll make sense. But those are your steps. Now, with this problem, we can see they've labeled their points, -1, 2, and 2, 4. They labeled it, okay? Well, they labeled x1, y1, x2, y2, and then they plugged it in. They wrote their formula, they plugged it in, then they went ahead and simplified it and solved it. So all I did was just generalize the steps to make it work for whatever I'm doing. Now it says, show that points 1, 2, 3, 1, 4, 3 are the vertices of a right triangle. Mr. Emmy.
Yeah.
This involves a lot. Right triangles, right? How do you know if something is a right triangle? 90 degrees, right? So you need to figure out one of those angle measures, right? You got 3, you need one of them to be 90. So, a couple different ways to do this. Now, who is at home that I can pick on? Mr. Schuler. Zach?
I left. I go get.
Sarah?
Yeah.
Sarah,
Yes.
what do you know about 90-degree angles in algebra?
About
We learned something. Do you remember it?
no.
You don't? You don't? What type of lines intersect at 90-degree angles?
Right angles.
Yeah, but it starts with P. It's a really long word.
I don't remember.
Rhymes with perpendicular. It starts with a P. Let's go with Jagger. Can you help us out here? What word starts with a P, ends in perpendicular?
Perpendicular.
Perpendicular. And Rachel, what do we know about perpendicular lines? They do, but what about their slopes? Well, those would be perpendicular or horizontal, and a vertical line would be perpendicular. But there's something about their slopes. And Maggie, do you know anything about their slopes?
Of perpendicular lines.
Yep.
They're opposite reciprocals.
Very good. They're opposite reciprocals. So, in order for me to show that a triangle is a right triangle, I actually have to find the slopes between the vertices, okay? Because that would be like the line, right? So up here, what they did, okay, is they actually found the distances, okay? So they went through and found the distances using the Pythagorean theorem, okay? And then what they did was they used all of that information. They used all that information in conjunction with the slopes, which apparently got combed. Okay, and Mark, the other thing they did here, okay, if it was a right triangle, right? Ready for this? Because there's more than one way to do it. My way was to find the slopes. Their way was to find the distance and see if it upheld in the Pythagorean theorem, right? That's what they did. They found the distances, okay, and they put it into a squared plus b squared equals c squared. Now for me, I just would have found the slopes like this. I would have done this. I would have said, okay, 2 minus 1 over 1 minus 3. I would have said that's 1 over negative 2. Then I would have said 1, 2, and 4, 3. I would have said my slope here was 2 minus 3 over 1 minus 4. So it would have been negative 1 over negative 3. So that's 1/3. Then I would have done 3, 1, and 4, 3. And done 1 minus 3 over 3 minus 4. Right? And I would have gotten negative 2 over negative 1, which was 2 over 1. And I would have looked at these slopes here, here, and here. And I would have said, hey, the red one and blue one are opposite reciprocals. And that's a triangle. Okay, I would have plotted, I would have graphed it, plotted those points, been like, we got a triangle. My slopes are perpendicular, we're good to go. A little bit harder of a problem is on the next page. Up here. Okay, they said determine whether the set of points is collinear. Well, Caitlin, can you hear me? What about Kelsey?
Yes.
Kelsey, what does collinear mean?
They're on the same line.
Yeah, you're right. They are on the same line. So if these points are on the same line, then if I find the equation of the line that contains two of those points, then if I compare it to the line that contains the other 2 points, then I'm good to go. So I went about it in last period by writing the equation of the line between A and B and C and comparing them. I found that those 2 lines were the same. They were like y equals, let me see, it was negative 4/3 x plus like 26 over 3. That's what I found the 2 lines to be. Now, what they did here was they said, hey, well, we can use the distance formula for that, okay? So let D equal the distance between A and B, and let D2 equal the distance between B and C, and let D3 equal the distance between A and C. All right, so they did that. They calculated it here. And when they found that distance, okay, which they got 5, 5, and 10, they said, so the set of points is collinear because D1 plus D2 equals 5 plus 5, which equals 10. All right, and they said, these 3 points are placed in the figure, so they graphed it. And they said, well, they appear to be in the same line, and the distances between A and B and C equals the distance between A and C, so therefore they must be. I'm not a big fan of that way because my mind kind of thinks outside the box a little bit. And I was like, well, what if it was like a triangle or something? You know? What if it was like 45, 45, 90? Okay? And they're just giving me a weird looking picture. So I like my way in writing the equation along. Okay? But there's different ways to do these problems now, and that's what I'm trying to show you. There's not always one way to answer it. The way Mark might do it might be different than the way You know, Ryan does it, and it's the different way than what I do. All right. Now, the midpoint formula is quite simply the point that's in the middle. It's easy, right? When we're calculating the midpoint Marcus, okay, we add our two x's and then divide by 2. It's the average of my two endpoints, okay? The average. So I give you a little example there. Like what point's in the middle of -5 and 9, okay? Well, you do -5 plus 9, that's 4 divided by 2, that's 2. Then they do -3 plus 3, that's 0, divided by 2 is 0. So that's where the 0.20 came from. And they have a formula for that. Now, to start a class, and this is the last little bit, these two problems, we're not getting to the graphs today. But Emily said, well, we have X and Y coordinates. And I said, yeah, which help us to shift, okay? Not like a shift as wayside, but like a shift in a movement. They help us shift our graph. Now, this is what a shift is. You take this point right here. I'm going to call it F. So this point is F. And the shift is telling me go up 5 units. 1, 2, 3, 4, 5. And to the right 2 units. 1, 2. This is my new coordinate, and they call it A prime. So the coordinates of A prime are, well, if I add 5 units to my Y coordinate, -4 plus 5 is 1. And if I add 2 units to my X coordinate, which is -3, so -3 plus 2 is -1, that gives me my new coordinates of A prime. And you can see on my graph that it is -1, 1.
How'd you get -1?
A is -3, -4. So the shift is 2 to the right. So -3 plus 2. And then it's 5 up. So here, this I was calling B. So B prime would be, we'll take B and move it up 5 units. So 1, 2, 3, 4, 5. And to the right 2, 1, 2. So that's B prime. That is the point. Well, if I add 2 to -2, that's 0. And if I add 5 to -1, that's 4. Last but not least, this is C. So C prime would be add 5, 1, 2, 3, 4, 5. Number 2, 1, 2. So if we go up 5 from -3, that's 2. And if we go to the right, 2 from 1, we're at 3. Because it's 3, 2. Over here, we have, let's go, A prime, B prime, C prime, and D prime. So A prime, we're going to go from here, and we're going to go to the right 6 units, 1, 2, 3, 4, 5, 6. And we're going to go down 1, 2, 3. So from -3, 5, well, let's go to the right 6 unit from -3. So -3 plus 6 is 3. And down 3 from 5, that's 2. So we're at 3, 2. Let's call this one B. So we're going to go to the right 6. 1, 2, 3, 4, 5, 6. And now we're going to go down 3. 1, 2, 3. So to the right 6 from -5, that puts me at 1. Down 3 from 2, that puts me at -1. Let's call this one C. So we're going to go 1, 2, 3, 4, 5, 6. And down 1, 2, 3. So from -3, we add 6. That puts me at 3. From -1, we go down 3. That puts me at -4. Last but not least, D, we're going to go 1, 2, 3, 4, 5, 6. We're going to go down 1, 2, 3. That puts me at the point of 5 and negative 1.
So how many guys about? I mean, class doesn't. I'll be right back. I mean.
Unless you want to play another game.
No, it's fine.
All right, ready? Rock, paper, scissors, shoot.
Genuinely beat you in the game, though.
All right.